Good morning. This is Ramraj, Associate Professor and Head, Department of EAE, PSN College of Engineering and Technology. Today, I am going to take the topic of Cascade Control Scheme. Outline of my presentation. I am start with the introduction of Cascade Control Scheme, following necessity to go for Cascade Control Scheme instead of simple feedback control scheme. Then I am detailing about the Cascade Control Scheme, block diagram of Cascade Control Scheme. Then I am explaining the Cascade Control Scheme for various applications. Cascade Control Scheme. Generally, in process industries, initially we have used feedback control scheme. Simple feedback control scheme. Here, one measurement we have used, one manipulative variable we have used. For example, for P-only controller, C is equal to C suffix S plus Kc into error. Error is nothing but your Y suffix Sp minus Y, where Y suffix Sp is nothing but a set point of the measured value and the measured value is Y. Kc is nothing but your tuning parameter. C suffix S is nothing but your controller output for zero error, and C is nothing but your manipulative variable or controller output, where Y is your measured value and C is nothing but your manipulative variable. So we can say this one is simple feedback controller. But some applications, for effective output, for very good output, we need to go for Cascade Control Scheme. There we are making more than one measurement and only one manipulative variable only used. That's why we are saying this one is dual loop controller, where one primary controller and one secondary controller we have used. The other name for primary controller is master controller. Other name for secondary controller is slave controller. Now I am going to explain the simple feedback control configuration. Okay, this one is nothing but your continuous tilde tank reactor. Here, first let me explain the process. Here, the inlet is coming with the flow rate of F and temperature of T suffix I and the composition of C suffix AI, and the outletting flow rate is F and temperature of T and the concentration is C suffix A. First, I need to maintain the temperature of this T. So once you want to maintain or control this temperature, we need to make the measurement of this temperature. For that, I need one temperature sensor TT. That one is nothing but a temperature transmitter. This is used for making the measurement of this temperature. That temperature will be measured and given to the temperature controller. There only you are giving the desired set point value, and the measured value will be compared with the desired set point value, and it could find the deviation value error. According to that error, this temperature controller take necessary action in the process through control valve. This is what happening over there. This is simple feedback control scheme, where the measured variable is this temperature T and the manipulative variable F suffix C. Okay, with the help of this only we are maintaining the temperature of the reactor. Okay, but here the T responds much faster to changes in Ti. So this T will change with respect to T suffix I. This one is nothing but your disturbance variable. This will change this value of this T. Then another one is this coolant temperature. This one is nothing but your jacket. Through the jacket, the coolant is flowing and the coolant outlet is going like this. Why? What is the necessity we are going for coolant? At the time of reaction, enormous amount of exothermic heat will be generated. So to remove that heat, we are admitting the coolant. Okay, this coolant also affecting this temperature T. Okay, so this temperature value will be affected by this T suffix I and the coolant temperature F suffix C. T responds, I mean that this T responds much faster to changes in T suffix I, because this T suffix I directly affecting this T. Okay, but this coolant temperature first to go to jacket, then it will transmit to this temperature. Okay, this area. First this will affect this area, then affect this area. So T responds much faster to changes in Ti than to changes in T suffix I. So more effective to reduce the effect of T suffix I. More effective to reduce the effect of T suffix I. Less effective to reduce the effect of T suffix C. Next, we are going for cascade control scheme. Already you know the process of continuous chilled reactor. The inlet is coming with the flow rate of F and temperature of T suffix I and the concentration of T suffix AI, and the outletting liquid leaving with the flow rate of F and temperature of T and composition of T suffix C suffix A. Okay, I need to maintain the temperature of this T. So I need to make the measurement of this T value with the help of temperature transmitter TT1, and the measured value is given to the temperature controller 1. There you are giving the set point value. This measured value will be compared with the set point value, and it could find the deviation or error. According to that error, this temperature controller will estimate the control action. That control action will be given the output, controller output. That controller output is your set point for the coolant temperature. Now we need to control the coolant temperature. So we are making the measurement of coolant temperature, and the measured coolant temperature value will be given here. The measured coolant temperature value will be compared with the set point coolant temperature, and it will find the deviation. According to the deviation, it will estimate the control action. That control action will be implemented to the jacket with the help of control valve. The control valve is manipulating this value. Disturbance in TC can be efficiently compensated by TC2. Disturbance in TC. The coolant temperature disturbance can be compensated by the T suffix C2 secondary controller before the effect of TC is felt by the mixer. Two measurements are there. One is temperature T, the coolant temperature T suffix C. One manipulator variable, that one is nothing but F suffix C, where two processes are there. Process 1, reactor excluding the jacket, where measurement value will be T, controller is T suffix C1. In process 2, jacket, where measurement T suffix C, controller is T suffix C2. In process 1, reactor excluding the jacket, there the measurement is T, measuring device TT1, I mean that temperature transmitter 1, controller is T suffix C1. That one is nothing but your primary controller. Process 2 jacket, there the measurement is T suffix C, I mean that coolant temperature. The measuring device is TT2, temperature transmitter 2, and the controller is TC2, secondary controller. Now I am going to draw the block diagram for the Cascade control scheme. First, I am taking the reactor. That one is nothing but your process 1. The reactor output will be disturbed by T1. So after disturbing, the temperature value will be measured with the help of TT1, temperature transmitter 1. That value is given to this comparator. There you are giving the desired set point value. This measured value will be compared with the set point value, and it will find the deviation. That deviation is given as input to the temperature controller 1. Okay, this temperature controller estimates the control action, and the controller action will be giving the controller output. That controller output is set point for the coolant temperature. Okay, now we need to control the coolant temperature. I mean that we need to maintain the coolant temperature at constant value. So the process 2 is nothing but your jacket. There only coolant is flowing. We need to control the coolant temperature. So we are making the measurement of coolant temperature after disturbance. Okay, we are making the measurement of coolant temperature. That value will be given to the summing point. The measured coolant temperature value will be compared with the set point coolant temperature, and it will find the deviation. That deviation is given as input to the temperature controller 2. Now temperature controller 2 will estimate the control action. Okay, that control action will be implemented to the process 2 through the control valve. Okay, where for 2 reasons we are going for cascade control scheme. One is wherever the disturbance are associated with the manipulator variable. Here for control purpose we are using manipulator variable, but manipulator variable itself acting as a disturbance variable. That kind of situation we can go for cascade control scheme. Another thing is wherever the final control element, I mean that control valve giving non-linear response, that time also we are going for cascade control scheme. So cascade control scheme, whenever we are going, first reason is disturbances are associated with the manipulator variable. Then final control element giving non-linear response. So that kind of situations we are going for cascade control scheme. Next, I am going to explain the cascade control scheme with the distillation column. This one is top section of the distillation column. First, let me explain the process, then I am going to implement the control scheme. This one is the tower or distillation column top section, where the vapor will be overheated vapor will be coming like this with the help of condenser. This one is nothing but your condenser. With the help of condenser, the overheated vapor will be condensed. The condensed liquid will be deposited in the accumulator. Okay, the part of the liquid taken as output, the output is distillate. Another part of the liquid recycled back to the top tray of the distillation column as reflux. Part of the liquid taken as output, that output is nothing but a distillate. Another part of the liquid recycled back to the top tray of the distillation column, that one is nothing but a reflux. Here our objective is to maintain the temperature of the top tray. So that top tray temperature will be varying with the help of reflux flow rate. But reflux flow rate is not constant. This value itself making disturbance in the top tray temperature. So wherever already I told, wherever the manipulative variable disturbing the process, that time we are going for cascade control scheme. So the primary control scheme we are implementing first. First of all, I need to make the measurement of top tray temperature with the help of temperature transmitter. With the help of temperature transmitter, I make the measurement of top tray temperature TT. TT is nothing but your temperature transmitter. With the help of temperature transmitter, I made the measurement of top tray temperature. The measured temperature value will be given to the temperature controller. Okay, there I am giving the set point value. The measured value will be compared with the set point value, and it could find the deviation. According to the deviation, this temperature controller will estimate the control action. That control action will be given as output. That output is nothing but your set point for the reflux. The first primary controller output is set point for the reflux. Now, the reflux is measured with the help of flow transmitter FT, and the measured value is given to the flow controller. In flow controller, the measured value of reflux compared with the set point value of the reflux, and it could find the deviation. According to the deviation, this flow controller estimates the control action. That control action will be implemented to the process through this control valve, where the control objective is top tray temperature. I mean that measured variable. The manipulated variable is reflux rate R, and disturbance associated with the manipulated variable is reflux rate, where the primary controller is T suffix C, secondary controller is F suffix C. Next, I am going to explain the cascade control scheme with the heat exchanger. So this one is nothing but your heat exchanger. Here, this one is nothing but tube side. This one is your cell side. Through tube side, we are admitting the process stream. The process stream is going like this. Okay, we need to maintain the process stream at a particular temperature T. Okay, through tube side, we are admitting the steam for heating the process stream. So, if you are varying the process stream flow rate, the temperature of the, if you are varying the steam flow rate, the process stream temperature will be changing. So, this T is nothing but your controlled variable. The process steam flow rate, the steam flow rate is nothing but your manipulated variable. Now, I am going to implement the cascade control scheme for this process, where the steam flow rate is keep varying. The steam flow rate is keep varying. Because of this reason, the process value will be getting disturbed. So, the steam flow rate is manipulated variable. Here, manipulated variable itself disturbing the process. That's why we need to go for cascade control scheme for this case. Okay. Now I am going to explain the cascade control scheme. Now, we are admitting the process stream through the tube side of the heat exchanger. The liquid is leaving as outlet. The outlet liquid temperature is T. Here, we need to maintain the temperature of this outlet liquid temperature. Okay, that temperature value will be measured with the help of temperature transmitter, and the measured value will be given to the temperature controller. There, you are giving the desired set point value. The measured value will be compared with the set point value, and it could find the deviation. According to the deviation, this controller will estimate the control action, and the estimated control action will be set point to the steam flow rate. Okay, now we are making the measurement of steam flow rate directly, and that value will be given to the flow controller, and the measured value will be compared, measured steam flow rate will be compared with the set point value, and it could find the deviation. According to the deviation, the valve will manipulate the steam flow rate. Okay, where the control objective is T, the process stream outlet temperature will be maintained at T suffix Sp. So control variable is T and the manipulator variable is steam flow rate. Generally, in cascade control scheme, secondary loop will be, two loops will be there. One is primary loop, another loop is secondary loop. Generally, in cascade control loop, cascade control scheme, secondary loop will be flow control loop. Flow control loops are almost always cascaded with the other control loops. I mean that other control loop means primary control loop. Generally, in cascade control scheme, two loops are there. One is primary loop, another one is secondary loop. Secondary loop is inner loop, primary loop is outer loop. Inner loop must be very faster than the outer loop. Secondary loop is very faster than the primary loop, or inner loop must be very faster loop than the outer loop. Otherwise, cascade control implementation is meaningless. So generally, inner loop must be take action very fast compared with the outer loop. So with this, I am going to stop the cascade control scheme. Thank you.